So we were discussing with RC circuit. Next is the voltage transient. We need to find out how the voltage is varying while we switch on the circuit through an RC circuit. Okay. So what is the voltage variation, or what that is called the voltage transient? That means what do you mean by transient? As time varies, what will be the response of the circuit in terms of voltage? Okay. As time varies, what is the response of the circuit in terms of voltage? So first we need to find out the voltage across the capacitor. Okay, then we go to the current through the circuit. So first we will analyze the voltage transient or the voltage across the capacitor through an RC, across an RC circuit. Okay, so first we will apply the KVL. Okay, Kirchhoff voltage law we will apply to the loop. Okay, so while applying the KVL to this RC circuit, what we will get, the voltage applied, that is V, is equal to the voltage across the resistor plus the voltage across the capacitor, isn't it? The total voltage V is applied, so V is equal to voltage across the resistor plus the voltage across the capacitor. So what is the voltage? V is equal to, what is the voltage across the resistor? R into I. Okay, what is the voltage across the capacitor? Let it be VC. So VC is the voltage across the capacitor, and R into I is the, V is equal to IR. So I into R is the voltage across the resistor. Okay, so next from rearranging some terms, V minus VC is equal to R into I. By rearranging, you will get like this. Now I you can substitute. What is I? That is the current. Okay, so current through the capacitor, you know. The current is, this is a series circuit. Both R and C, they are connected as series. So the current will be same, isn't it? The current will be same through R and C. So what is the current through capacitor? You know that current I is equal to C into dV by dt, isn't it? So substitute for current I is equal to C into dV by dt. So dVC by dt. VC means the voltage across the capacitor. So what is the current through the capacitor? I is equal to C into dVC by dt. This equation you already know. You have already studied in your plus 2 classes and all. So I is equal to C into dVC by dt. Okay, now you rearrange the term again. So divide by RC. Okay, so divide the whole equation by RC. So on the LHS side, you will be getting V minus VC divided by RC is equal to dVC by dt. Or you can write dVC by dt is equal to V minus VC by RC. So this is the whole differential equation. This is the whole differential equation that you need to solve. What is the differential equation of the voltage? dVC by dt is equal to V minus VC by RC. So in MATLAB, you will be able to solve this differential equation and find out the solution for VC. So here with respect to T, which is varying the factor which is varying is voltage across the capacitor VC. So VC is varying with respect to T. Okay, so if I put this differential equation in MATLAB and solve for VC, voltage across the capacitor. So ultimately you will be getting the solution VC is equal to V into 1 minus e raised to minus t by RC. That means we are closing the switch. Here we are closing the switch. Okay, so while once we are closing the switch, this capacitor will get starts charging. From this V voltage, it starts charging. Okay, so the ultimately as time passes, okay, as time passes or as time increases, the voltage across the capacitor will increase. Voltage across the capacitor will increase as time increases, and now it and finally it will go to a steady state value. It will become a steady state value. Okay, and it finally approaches the V voltage. It finally approaches the V voltage in a steady state condition. Okay, and the current will be decreasing because as the voltage across the capacitor increases, the current will be automatically decreasing. Okay, I hope this is clear. Now, so VC, you will be getting the voltage across the capacitor by solving the equation will be VC is equal to V into 1 minus e raised to minus t by RC. By analyzing this solution, you can analyze that as t increases, here as t increases, this term e raised to minus t by RC will be decreasing. So what happens to 1 minus e raised to minus t by RC? 1 minus e raised to minus t by RC will be increasing. As t increases, e raised to minus t by RC will be decreasing. So 1 minus e raised to minus t by RC will be increasing. So ultimately the voltage across the capacitor will be increasing and will reach to a final steady state value. I hope voltage transient is clear for you. Now we will look into the current transient through an RC circuit. Again, if you want to analyze the current transient, again you apply the KVL. Okay, so what is KVL? KVL is the total voltage V. Total voltage V is equal to R into I. Okay, R into I is the voltage across the resistor. Plus, what is the voltage across the capacitor? The voltage across the capacitor is 1 by C integral I dt. Okay, so total voltage V is equal to voltage across the resistor plus voltage across the capacitor. What is the voltage across the capacitor? 1 by C integral I dt. That also you have studied. Okay, now differentiate this whole equation with respect to t. Okay, while once you differentiate with respect to say t, you will be getting r is a constant. So r into differentiate with respect to t. So r into di by dt plus 1 by c, and you are differentiating this integral part. So integral and differentiation will be getting cancelled because you are going to differential d by dt of integral I. So integral and differential will get cancelled and the remaining will be I. So 1 by C is a constant again. 1 by C into I is equal to what is the differential of V voltage. V can be a 5 voltage or 12 voltage. So V is a constant actually here. Here V is a DC voltage. So this is a constant DC voltage. So V, when you differentiate V since it is a constant value, while differentiating you will be getting 0. Okay, now divide throughout by R. So you'll be getting di by dt plus 1 by RC into I is equal to 0. So this is your whole differential equation that you need to put in your MATLAB. And after solving this differential equation, you will be getting the solution as I is equal to, that means current. You are solving for the current value. So I, the current value is equal to K into e raised to minus t by RC, where K is a constant. So here, please look at the equation. When t increases, here as t increases, time increases. What is t? Time. Time increases, what happens to the current? Current decreases. I is equal to k into e raised to minus t by RC. As t increases or time passes, the current will get decreasing. So this is a solution. I is equal to k into e raised to minus t by RC. Now if you want to find out this k value. K value, in order to find out the k value, you need to put the initial condition. Okay, so for solving this equation and finding out the correct solution, we need to find out this k value, constant k value. So in order to find the k value, you need to put the initial condition. So please understand that what happens when the current, when the switch is closed. That means when the switch is closed, what happens to the current? Here the current starts flowing, isn't it? When the switch is closed, in this figure you can see, while we closing the switch, while we close the switch, the current starts flowing here. Okay, initially the voltage across the capacitor. What is the voltage across the capacitor? Even though the switch is closed at t equal to 0, the switch is closed. The voltage across the capacitor will still be 0, because because the capacitor will not entertain a sudden change in voltage. So the capacitor voltage will still be 0 at t is equal to 0. Okay, but this voltage V, this V voltage we are applying here, that voltage will be applied across the resistor, isn't it? Because the voltage across the capacitor is 0. So this V is applied across the resistor. So what is the current I? The current I will be V by R. The current is flowing at t equal to 0. Isn't it? At t equal to 0, what is the current? Current I is equal to V by R, because this whole voltage is applied across the resistor. So current I is equal to V by R. So that is the initial condition. At t is equal to 0, you need to put the current I is equal to V by R. So now we will find out the k value. Okay, so using this equation, I is equal to k into e raised to minus t by RC. This is our solution. Now we will find out k. Now we will find out k. Okay, so what is at t equal to 0? So please put t equal to 0 here. So e raised to minus t by RC. E raised to 0 is 1. So k into e raised to 0 is equal to, what is I value? V by R. So at t is equal to 0, you put I equal to V by R. So you'll be getting k as V by R. So what is I value? I is equal to k into e raised to minus t by RC. So what is k? K is equal to V by R into e raised to minus t by RC. This is our final current. This is our solution. I is equal to V by R into e raised to minus t by RC. And current, as time increases, the current will be decreasing. Okay, now we will see in MATLAB. Okay, I hope this is clear. So now going to MATLAB, here you can see first I am getting the voltage transient. I am trying to do the voltage transient. And one more factor is there, the RC time constant. What is RC time constant? This R into C value. R is the resistance value and C is the capacitance value. Okay, this R into C value, that will be your RC time constant. In an RC circuit, the RC time constant will determine the rate of charge of the capacitor. The capacitor is charging, isn't it? So the rate of charging of the capacitor will be how fast the capacitor is charging. That will be determined by the RC time constant, R into C value. So that we call it as RC time constant, the rate of charging of the capacitor. I hope this is clear. Now we need to find out the solution for the differential equation. So we need to find out Vc of t, isn't it? So I am taking as Sims. Sims is a symbolic representation that we have already seen in the last classes. Okay, so symbolic in the symbolic representation, I am finding Vc of t. Vc of t, and initially I am just taking some variables. What is your voltage applied? The voltage applied is 5 volt. Then R value, RC circuit. So I need to find out the R value. Okay, so what is R value? R value is equal to 3. Now what is the C value? C value equal to 1. So let me change the font size, and it will be more clarity. It will become more clarity. Okay. So I have changed my font size. Okay, now it's very clear for you. V is equal to 5 voltage. R is equal to, let the resistance value be 3 ohm, and let the capacitance be 1 farad. Okay. Now I am putting as my equation. What is my equation? What is my equation? Here my equation for the voltage is equal to dVc by dt is equal to dVc by dt equal to V minus Vc by RC, or 1 by RC into V minus Vc. So on the left hand side you have dVc by dt, right hand side you have 1 by RC into V minus Vc. The same equation I am implementing here also. dVc by dt, diff of Vc comma t, dVc by dt, then equal to, okay, equal to 1 by RC into V minus Vc. Okay, that is my equation. I am putting it as an equation EQN. Okay, now what happens? I need to find out the initial condition. What is the initial condition here? Here I am putting as the initial condition the the capacitor voltage at time t equal to 0. What is the initial voltage when switch is closed? The initial voltage, even though the switch is closed, the capacitor voltage will be equal to 0, isn't it? So the condition will be Vc of 0 at time t equal to 0 will be equal to 0. Okay, now you solve the equation using the equation and the condition using DSolve. So DSolve is a keyword for finding the solution. So DSolve of equation comma initial condition. So this is the initial condition, Vc of 0 is equal to 0. Now equation you know already know, and using DSolve you can find out the solution. Hope this is clear. Okay, now you found out the solution. Now you want to plot the solution. So this solution you are finding as a symbolic variable. Okay, since you are using SYMS, Sims, this you are finding out in symbolic representation. So in order to convert it into a numeric representation, in order to find out it in a numeric representation, you want to convert this solution SOLN. Okay, how can you convert the solution? Okay, using subs. So using subs you can convert the solution into a numeric representation. So using subs of solution, you are converting it into a numeric solution S. Now you put t equal to some t value 0 to 10. I am ranging from t value, time value 0 to 10. Okay, now I am plotting my t comma S. What is t? T is my time, 0 to 10, x-axis. Okay, what is my s? S is my solution. Okay, t comma s, then k is for black color, and line width I am changing it to 2 for clarity, more clarity and thickness. I am changing my line width, and I am going for title. Then what is the title? Voltage transient of RC circuit. Voltage transient of RC circuit. My X label is T, my Y label is voltage across the capacitor. What is the Y solution? What is the solution? Voltage across the capacitor. So Y label is voltage across the capacitor. I hope this program is clear for you. Now I am going to run this. So while I run this, I will get an output like this. Here you can see the capacitor is charging. The capacitor as time, this x-axis is the time, y-axis is the voltage across the capacitor. So as time increases, the voltage across the capacitor gradually increases and becomes a steady state value. Okay, I hope this is clear. Now we will analyze the current transient of the circuit. Okay, so current transient, similar way you can analyze Sims I of t, since you are using the current. Okay, now voltage 5, then R equal to 3, C is equal to 1. So what is RC? R into C is equal to 3. RC time constant. It is determining the rate of charging of the capacitor. So R is equal to 3 and C is equal to 1. Now my equation of the current. So let me take this. The equation of the current transient is nothing but di by dt plus 1 by RC into I is equal to 0. This is the differential equation. Di by dt plus 1 by RC into I equal to 0. So let us put this in MATLAB. So di by dt. So differential of I d df diff I comma t, di by dt plus 1 by RC into I. That means I by RC. 1 by RC into I, or I by RC equal to 0. That is my equation, and I am putting it to a variable called equation. Now what happens? The condition. What is the initial condition? I of 0 is equal to V by R. What is at t time t equal to 0? What is the current? I've already told you the current will be V by R. Okay, at time t equal to 0, my initial condition is V by R. So I am putting it to equation comma condition. I am putting it to DSolve for solving the equation. So DSolve of equation comma condition. I will get the solution SOLN. Now what happens? Vary the time t is equal to 0 to 10. Vary the time, then subs. Using subs, you are converting the solution symbolic into numeric variable. Now you are plot t comma s. Then you are changing the k and line width. K means black color, line width you are increasing to 2. Okay, now title. What is the title of the figure? Current transient of RC circuit. X label is time, and what is the Y label? Current through the current through the capacitor. Current through the circuit, or current through the capacitor. I hope this is clear. Let us now analyze what is the output. You can see that the current is decreasing. As time increases, the current is decreasing. Hope this is clear for you. Okay. Now we will go to the response when using the voltage, a different voltage. So far we have studied for applying a DC voltage. So if you have given any other voltage, like V is equal to some 5 into e raised to minus t. See, so far you have applied voltage equal to 5 volt. It is a DC voltage. Now there are some variation. Suppose if there is some instantaneous variation in the voltage also. Okay, now we will see what is that. Okay. So here suppose the voltage V is equal to 5 into e raised to minus t ut. That is the applied voltage. Suppose the applied voltage across the RC circuit is 5 into e raised to minus t ut. What is U of t? U is a unit step signal. I don't know whether you have studied this. U is a unit step signal. Okay, so unit step signal, it's having values, value 1. From time t equal to 0 onwards, it will be having a value 1. Okay, so 5 into e raised to minus t into ut, u of t. It will be u of t is a unit step signal, unit signal. Okay, so unit signal, it is having a value 1 from time t is equal to 0 onwards. Okay, so in effect, this value will be 1. U of t will be 1. So what is the voltage? 5 into e raised to minus t. The same equation, R into I, Kirchhoff voltage law, R into I plus 1 by C integral I dt equal to voltage V. The same equation you have seen by applying the Kirchhoff voltage law. Differentiate with respect to t. Now R into di by dt plus 1 by C. Integral and differential will be cancelled. So 1 by C into I is equal to d by dt of this voltage V. Okay, now divide by R. So di by dt plus 1 by RC into I is equal to 1 by R into dV by dt. 1 by R into dV by dt. So put this equation in MATLAB. Here V is actually 5 into e raised to minus t. Please understand that V is 5 into e raised to minus t. Okay, so put this in MATLAB. dy by dt plus 1 by RC into I is equal to 1 by R into dV by dt. So in MATLAB, I have put this. Okay, you can see here. V is equal to what is my V? V is equal to 5 into e raised to minus t. So initially sims, then for what is V? V into e raised to 5 into e raised to minus t, exp of minus t. Then R is equal to 3. Then what? R equal to 3. Then C is equal to 1. Okay. Now equation di by dt plus I by RC is equal to diff of, that is dV by dt. dV by dt by R. dV by dt by R. That is my equation. I'm putting that equation in a variable called equation. Now the initial condition. The initial condition I of 0 is equal to the voltage at time t is equal to 0. What is the voltage? Here what is my voltage? V is equal to 5 into e raised to minus t is my voltage. So at time t equal to 0, what is my voltage? Initial voltage e raised to 0. Time t equal to 0. E raised to 0 is 1. So the initial voltage will be 5. So what is the current? 5 by V by R. So the voltage is 5 by R. So V by R. Okay, or 5 by R. So the initial current will be 5 by R. I hope this is clear. So that is the initial condition and you have put the equation. Using DSolve, you can find out the solution. Now time t equal to, you are waiting the time t from 0 to 10. Using subs, you are converting the solution and now we are plotting t comma s. Now give the title current transient of an RC circuit, time t, then label, y label current through the capacitor. Okay, I hope this is clear. Okay, now you find out the solution. Okay, you will be getting the current transient like this. Okay, you will be getting the current transient like this. The current is again decreasing and finding a steady state value. Okay. And now you can have another thing. So, another thing that's having the different RC time constant. The different RC time constant. Okay. So initially, for different RC time constant, I am plotting the graph. Initially, Sims VC of t, that is my voltage VC, a voltage across the capacitor VC of t, V equal to 5. My RC time constant I am putting as R1 equal to 3, C1 equal to 1. So what is my R into C? RC time constant is 3. So in the comment I have written as RC time constant is equal to 3. So initially I have chosen my RC time constant R1 into C1, that is RC is equal to 3. Now I am putting as TC1, that is time constant. What is TC? TC represent the time constant variable. Okay, TC is a time constant, 1 is equal to R1 into C1. Now you put the equation. Okay, equation is differential of VC, the same equation. Okay, no need of explaining this again because the same equation you are putting. differential of Vc comma T is equal to the same differential equation of the voltage across the capacitor. V minus Vc by Rc. So instead of R into C, what is R into C? Time constant. Tc1. Instead of R into C, so that is a time constant Tc1. Okay. Now we can see here the condition. Now we can see here the condition Vc of 0 is equal to 0. The same condition, initial condition, and using desolve you are putting equation comma condition and you are finding out the solution 1. Okay, for first RC time constant, RC is equal to 3. Now the second solution. Now change the RC time constant. So TC2 is equal to 2 times the RC time constant. So 2 times the RC time constant. So initially the RC time constant was TC1. Now you multiply with the 2. So 2 times the RC time constant will be TC2. Now we put the equation again. So same equation you change V minus Vc divided by TC2. The same equation dvc by dt is equal to V minus Vc by TC2. Okay, now you have put the equation 2. Now we have put the equation 2 and using desolve you can put equation comma condition and you find out the solution. Okay, solution 2 also you got. Now 3 times the Tc time constant. 3 times the Tc first time constant will be Tc3. Okay, now equation you are putting as Tc3. V minus Vc by Tc3. Okay, now you desolve using the equation comma condition. Condition is same. So condition you need not rewrite again. So the condition is same. The equation is changing. Now you find out the desolve and solution 3. Okay. Now we plot all the solution. First solution you are converting into S1. Second solution you are converting into S2. Third solution you are converting into S3. Okay. Now you plot T comma S1. Now you plot T after you plot 1, then you hold on. Okay. You know the relevance of hold on. I'm not repeating that. Plot of T comma S2. Okay, the second plot and then also you hold on. Okay, after that plot of T comma S3. Okay, now you can type. So I think this much is clear. So initially you are finding out solution 1, solution 2, solution 3. Then you are defining your time T. Now we are finding S1, S2, S3. The three solutions. Solution 1, solution 2, solution 3. Now we are plotting T comma S1. After that hold on. Then T comma S2. After that hold on. And T comma S3. Now we are putting the legend because you want to know which graph belongs to which one. Okay, so now we put the legend as RC, then 2RC and 3RC. RC for the first graph, 2RC for the second graph, 3RC for the third graph. So when you put the legends like this, you will be getting a window mentioning the labels. So in effect, you are mentioning the label RC, 2RC and 3RC. You can easily identify when you get the figure. Okay, then the title, voltage transient of RC circuit. The next label is time. What is I label? Voltage across the capacitor. Okay, now you run this. So you'll be getting 3 graphs. Okay, you'll be getting 3 graphs. First graph is in red color, second graph in green, third graph in blue. I have purposefully given like that. So this is the label. RC, first label is RC, second label is 2RC, and the third label is 3RC. So the black color is 3 times the time constant, green color is 2 times the time constant, and the red color is RC time constant. So as you can see here, as the time constant varies, the rate of charge of capacitor also varies. As the time constant varies, the rate of charge of capacitor varies. Okay. So for RC time constant, that is the red color graph. Okay, it is attaining the voltage faster compared to the 2RC. I hope this is clear. With this, we will wind up this particular session. Thank you.